video, I'm going to be melting glass, dichroic glass specifically. I'm going to see what interesting combinations I can make. The dichroic glass, as you can see, is here. I just bought this off AliExpress recently. It was like $15 or $20. Before getting the dichroic glass, I was experimenting with just broken glass pieces from like bottles and stuff. So I was able to mold a glass piece like this, for example. Initially, the reason for this whole like setup thing here was I was gonna melt photochromic glass. I wanted to recreate on the Clyde Spencer's YouTube video, but I don't really have access to a bunch of the equipment, and it was like too expensive. So, I mean, as you guys can see here, I literally just took apart a broken microwave and repaired it, and then, well, I didn't really repair it. I just changed it so that I can like use it as its original function. And then that just heats up a microwave kiln, which I got off like Amazon for like $30. And then this is the heating element inside of it. I forgot what metal it was, but it heats up to like 800 degrees Celsius, I believe, maybe a bit less. But as you can see, it heats up. You put the glass on the microwave kiln. I've got microwave kiln paper, so it doesn't damage the actual like kiln surface. Anyway, after I put the broken glass onto the microwave kiln, I put it in the microwave, and then I need to let it heat up. You guys can see here. Oh yeah, I need to connect up this thing here. It's a ballast system. This is from another video, by the way. So anyway, let me just connect this up. I just connected it up. As you guys can see, pretty sketchy stuff, right? Also rigged this whole system here up to connect the microwave transformer on this section up here. Yeah, it's really rough. It's pretty dangerous. So not just that, if there is leakage. Oh yeah, but initially I was gonna have two magnetrons connected like through a H bridge, or in other terms a T. I think it's called a magic T. Initially I was gonna have a magnetron up here and then a magnetron on the side, and then it was either gonna increase the basically amplitude of the signal. The only downside to this was it wasn't like a constant amplification rate. It wasn't a constant amplification rate. It was more like a chance of it being amplified, but the smallest amplification it can be is the minimum of what the actual power is of one magnetron. It's hard to explain, but I initially 3D printed it, and I was going to connect it like this, and then I had the other one, or it was a bit bigger than this. I was going to have the other one, I believe, connected like that. It was going to feed into the... Anyway, I decided not to bother with this. There's too much complication involved and too many calculations I already did, so I decided I might as well just scrap one up. And initially my first idea was to actually put, so you can see here, you can take out this section of the magnetron, and then this was going to feed directly onto here, but I needed something to reflect the microwaves from hitting back the magnetron, it's the waveguide inside the microwave, which you can see here. And I didn't have a waveguide, so I decided to scrap that idea. Anyway, it was more. There's obviously more stuff involved than just these two things here. It was way more complicated. I was gonna add like a I forgot what else I was gonna add, but there was a lot of stuff I was gonna do to this. But I just decided to leave this. Just leave this for the leave it for now. I'm just gonna use a single magnetron operated at I believe 800 watts. I don't know, I got this from the rubbish, but it works well. Anyway, you can see these are the glass pieces I've melted so far. They're basically just scrap glass, like I was saying. So now I'm gonna just put some dichroic glass in, make a bunch of combinations and see what comes up. I'll start off with just using dichroic glass as a to see what it would turn out to be, and then I'll use mixtures of dichroic glass and just scrap glass. It's important to note that I put this ballast here, or this inductor, connected to the primary of the transformer to limit the current. Basically this is because the magnetron acts as a negative impedance load. What that just means is the hotter the magnetron gets, the more current it's going to draw. And well, the microwave itself combats that through something called magnetic shunts. Basically all it does is it causes the field lines to not couple directly into the secondary, but also couple into the magnetic shunts, and that drops the energy by converting it into heat energy instead of electrical energy. And this basically saves the magnetic fields from actually going inside the microwave core, which can saturate it. And then once the transformer core is saturated, there's going to be significant heat losses. The ballast or this thing here is just important to make sure that nothing wrong happens. It does get very hot, so as you can see, I put it on some heat sinks, which, I mean, it's mainly to protect the wood. It's not going to actually work as a proper heat sink, but I mean, it works. I probably should have used some more like lesser conductive material, because it's still going to heat up the wood underneath with the heat sinks. But yeah, I mean, it works. It's been working fine. The actual duration runtime of the microwave kiln, I put it in for about 13 minutes, and then obviously I opened the door, let it cool down. Initially when I started using it, you can see here that the kiln started to like, you can see it started to like break. Apparently this is like normal, but it's better to be on the safe side. So I'm just gonna open the door up slowly, and then like 5 minutes later, if it's cooled down at a slow rate, I should be able to take it out. As you guys can see here, I've placed the dichroic glass onto the kiln paper. The only downside with this setup here is the actual melted glass is then going to stick onto the kiln paper. If you guys see here in previous print melts, I guess, the kiln paper printed engraved some sort of pattern into the actual glass, and it was really hard to actually get the kiln paper off of it, but I mean, it comes off eventually. It hasn't fully come off on this one here. But yeah, anyway, I'm going to test out 2 layers of dichroic glass on top of each other. I'm not going to use scrap glass first, because just in case, you know, the coefficient of expansion isn't the same with these 2 glasses, you know, I won't waste dichroic glass in the process. I've got a transparent dichroic glass, and then this one's more opaque, so this color's pretty hard to see. See, it goes blue on a certain angle and then green on like the front side. Anyway, we can see what the pattern looks like when it's melted together. I've got the kiln inside the microwave. I've connected this up to the power supply.
A few moments later.
As you can see here, I've placed the glass in the actual, on top of the dichroic glass, and this is basically how I melt it.
A few moments later.
You can see here I've finished all the dichroic glass pieces. I've put them into separate bags, and I've labeled the time limits for which ones I've spent. You can see here when I fused the dichroic glass for a 12-minute time period, the glass was very opaque. It's like really hard to see any features of the dichroic glass. There's even this section here was just a transparent piece of dichroic glass, and it's a clear piece of glass. I then moved down to 8 minutes, which was a big decrease. You can see there's a massive change in the actual features of the dichroic glass, like it's much more visible. Some of them had pretty cool features, like this one had a holographic film on top of it. A lot of them had bright dichroic features to it, while other ones had fairly opaque ones. Overall, I was really happy with these results, but I feel like some of them, like this one for example, is really bad. I then moved it down to 7 minutes, and you can see here when I put this on in for 7 minutes, you can see like the glass didn't fully melt. But this one did, so I feel like a good time for actually using the dichroic to make the dichroic glass would be between 8 minutes and 7 minutes. Anyway, when conducting my experiment, I was looking for qualitative features, of course, because you can see here the main qualitative features is the brightness of the dichroic glass, and I wanted to see what features I wanted to see features that meant that the dichroic glass would be the most visible and brightest, and I could see that it was fairly evident that 7 minutes was the one that represented the highest amount of brightness of the dichroic glass. Obviously, the longer it stayed in, the worse the dichroic glass color was. I'll take them out of the plastic bag so you can guys have a look more clearly. As you can see here, this is the 12 minute glass dichroic glass pieces. Eight-minute glass pieces. I did a lot on this. This is probably the most I did.